Alright, welcome to the last part of the videos. Okay, so I want to talk about the characteristics of image for both mirror and lens. We have mirror and lens over here. I combine everything. I want to make comparison between mirror and lens. I want to make comparison between converging and diverging also. Okay, in fact, what is mean? Okay, firstly, what is mean by converging? Converging means it can focus the light. This is the first thing you should know. And this converging means it can focus light. Focus light, sorry. Converging means it can focus light. Normally, this one, it has positive F. Positive F. For converging, is always positive F. Diverging means it diverge the light. Diverge the light means it spread the light away. It doesn't focus the light, it spread the light away. Spread light away. So spread light away from the focal point. So this one normally F is negative. So diverging normally has F negative, converging has F positive. So mirror for converging this concave mirror is called converging because we just look at the shape. This shape, this concave mirror, surely it focuses a light. Just use our common sense and we can see. Like you see, the light comes like that. Surely it focuses a light. Surely it focuses a light, isn't it? Comes parallel. The light comes parallel. It surely focuses the focal point. You see not? It focuses a light. So this concave mirror is a converging mirror. Converging mirror. It has F positive. F positive. But this one, this mirror, it won't focus a light. It surely will diverge a light away. You see or not? Okay. Of course, don't. Okay. I don't want you to draw on the line on the surface. I want you to draw on the line. I already draw on the line. You see? I want you to draw on. I want you to use the line here. I want you to use the line over here. I want you to use the line over here. The light only converge or diverge from this line. The mirror has their own line. The lens also has their own line at the middle. I want you to use the line. Okay. Don't go to converge at the line. So you see this one, the light for concave mirror. It surely converge to the focal point. Wait, the shape of the mirror itself already show that it can focus the light. So it has F positive because converging. This one, this mirror, convex mirror, you use your common sense. Surely it spread the light. It won't focus the light, isn't it? So the light parallel. Surely it diverge the light away. Look at the shape. The shape diverge the light away. Diverge the light away. Like that. Diverge the light away. So it diverge away from the focal. Diverge the light away. So like this one, diverging light, spread the light away, F negative. Like convex mirror, F negative lah. Okay. Like look at the lens. Lens, the fat guy. The fat guy normally focus the light. Just like your what do you say, the one you use in the lab, they call it the magnification glass. The magnification glass. Still remember the magnification glass? Magnification glass is a convex lens. So same thing. The magnification glass, it can focus the light. It focus the light. A fat guy always focus the light to the focal point. It focus the light. This one, this is a reflection. It reflect the light away. This one is refraction. The light can pass through. It's different. See? The mirror, the incident ray and reflected ray. The light cannot pass through. But for the lens, the light can pass through. The light can pass through. Go to the other side already. Refracted ray, incident ray, reflected ray. This is reflected. This is refracted. Okay? So the other side. So convex lens can focus the light. The fat guy can focus the light, but the thin guy, it diverge the light. It diverge the light away. The thin guy, how it diverge the light? Surely it diverge from this side. See or not? It diverge from this side. course it diverges the light away. So this is the diverging lens. The diverging lens. So these two, okay, these two, of course, concave mirror, it has a positive F, and convex lens also positive F, because it focuses the light. Both of these are called converging. Hold on a second, like this. Okay. Both of these they are converging. They can focus the light. They can focus the light. This convex lens also can focus the light. So it's also converging. This is concave mirror is a converging mirror, so it has F positive. Convex lens is a converging lens, so F positive. But convex mirror is spread the light away, so it's a diverging mirror. Diverging mirror, F negative. Concave lens, it diverges the light away. It won't focus the light, it diverges the light away, so it's a diverging lens, so it's F negative. These two they are F negative. F. Understand? Concave mirror and convex lens, F positive. Convex mirror and concave lens, F negative. F negative. Converging, these two are converging, F positive. These two are diverging, F negative. Remember that. Yeah, it's just common sense. Look at the shape. Which shape can focus the light? Of course, the concave mirror and convex lens can focus the light, so this one should be F positive. F positive. This one, the convex mirror and concave lens, it cannot focus the light. It surely diverge the light away. Diverge the light away. Diverge the light away. Of course, this is the diverging mirror and diverging lens, so F negative. Then, okay, finish about that. Now I want you to look at about the characteristic of image form. Yeah, characteristic of image form. Okay. First of all, just want to rub off everything off here. I want to rub off this one. I don't want to mess up with my drawing. Okay, don't want to mess up my drawing. Now, I want you to, sorry. Okay. Yeah, look carefully. Now let's talk about the concave mirror. Yeah, concave mirror. So mirror, of course, incident ray and reflected ray. The light reflected away, isn't it? This is a converging mirror. Converging mirror means it can form real image. It can form real. Converging mirror, it can form two types of image. It can form real and virtual image. But for I should say like that. For converging, no matter it's converging mirror or converging lens, both can form real and virtual image. But for diverging mirror, it only can form one type of image, which is virtual image. Okay, converging can form real and virtual, but diverging only can form one type of image, which is virtual. Okay, you see the concave mirror and convex lens. What's the difference between these two? What's the difference? Concave mirror and convex lens, actually they are almost the same. Concave mirror and convex lens, the same thing about these two is both can form real image and virtual image. Real image, virtual image. You see that? It can form two images. And then for convex mirror and concave lens, both of these are diverging mirror and diverging lens. Okay, the same thing of these two is they can form only one type of image, which is virtual image. Virtual image, virtual image. The difference between these two, mirror and lens, is, let's look at the converging first. Converging. The concave mirror and convex lens, the difference of it is, of course, due to this is reflection. You know, this thing is reflection. This one is refraction. This one is refraction. That's why it's different. This is reflection and this is refraction. Okay, reflection means the light cannot pass through. The reflected ray is over here. Refraction means the light go to the other side. Go to the other side. You see, later on, you see, look at here. Get here. You see, both of these concave mirror and convex lens, they can form real and virtual image, isn't it? Real and virtual, real and virtual. The difference is this real image is formed same side as the object. This side as object. But this real image is formed at the other side of the object. And then for the virtual image is formed at the other side, but this virtual image is formed at the same side for the lens. Why the opposite? Real image for mirror, real image is at the left hand side. For lens, real image is on the other side, on the right hand side. Why got this difference? Because one is reflection, one is refraction. You see, for reflection, the real image, the reflected light is at the left hand side. The reflected light is at the left hand side. So to form real image, must be at the same side as the reflected ray. Remember the thing you have learned about the sign convention. The image distance need to compare with reflected ray. If same side is positive or real image, if opposite side is negative or virtual image, and the same thing. Goes back to here. The real image should form at the left hand side because the reflected ray is at the left hand side. The real image was formed at this side, same side as the reflected ray, and then it is a V positive. Yeah, this V is positive here, is a real image because it is formed at the place which have light. We have the reflected light. But if the image is formed and on the other side, this one has we can say here has no light. Here has no light means and the V over here, the V over here is opposite to the reflected ray, so that's why it's V negative. Understand or not? Here V positive because same side as the reflected ray. Okay. But for lens, the real image is formed on the other side because the light has already go to the other side. Refracted ray has go to the other side. This light can penetrate. For lens, the light can penetrate. For mirror, the light cannot penetrate. The light already go to the other side. So the other side can form real image because got light. Understand or not? Here at this side got light. So it can form real image here. Understand or not? But for this side, here has, we can say here has no light. No light. So no light means it's virtual image. Form virtual image. We get negative over here. Understand or not? That's the difference between a mirror and lens. Okay, mirror and lens. Because light cannot penetrate. So, but the lens, the light can penetrate. Okay, for mirror, the real image is at the same side as the object because the light is reflected back in the opposite direction. But for lens, the light has penetrated the lens, go to the other side, so the real image is formed at the other side. Okay. And then for diverging mirror and diverging lens. Diverging mirror, it only can form virtual image. So of course the image is formed at the place with no light. The reflected light is at the left hand side, so the virtual image is over here. You see that? Opposite to the reflected ray. Virtual image is here. The image is opposite to the object. But for concave lens, the virtual image is over here. Because this one, for mirror, convex mirror, the virtual image is at the right hand side. But for the concave lens, the virtual image is at the left hand side. Because why? the reflected ray already go to the other side. So virtual image must form at the place with no light. Here got light. Yeah, understand or not? Look back at the mirror. Here got light. Here no light. So virtual image should form at the place with no light. Okay, because reflected ray over here. And then this one, for lens, the light go to the other side. So here got light. So virtual image should form at the place with no light. So virtual image is over here. Understand or not? So just the difference, but the characteristic is the same. Virtual upright diminished. Okay, good. Now that's it. Now I want to talk about each of these image characteristics. I want to rub off everything of this of here. I want to rub off everything. This one, yeah. Do I need to disturb my drawing? Okay. I want to rub off everything. Yeah. Right. Just rub off first. Rub off. Yeah. Rub it off. Okay. Rub it off. Rub it off again. Rub it off. Now for this one, you see, look at the concave mirror. Yeah, concave mirror. If you object, if the object is more than the center curvature, very far away, this object one, it will form real inverted diminished, RID, read, real inverted diminished image over here. That means it form between the F and C. Form real inverted diminished image over here. Yeah, smaller, inverted, and real image. Yeah, it's real image because same side as the reflected ray. Yeah? It form near. When the object is very far away, the image is very near to the mirror. Now the object is going nearer to the mirror. Going nearer to the mirror. It at the center curvature. Okay. This is object 2. The image 2 will be here, same place at the center curvature also. Real inverted, same size. RIS, real inverted, same size. Same size. When the object go nearer, the image go further away. Do you see that? The image go further away. Now, if the object 3 between F and C, the object go even nearer, the image go even further away, become image 3. Real inverted, magnified, and the image is going bigger and bigger. From diminished, become same size, become magnified. Yeah. So object 3 has real inverted, magnified. And then go even nearer at the focal point, object 4. It will form two kind of image. It can be at the real inverted. This is actually real inverted, magnified also. It follow this one, real inverted, magnified, but it form at infinity, placed at infinity. Or it can also form virtual upright, magnified. Or it also can form virtual upright, magnified at infinity. So from this object 4 can form either real inverted magnified or virtual upright magnified. Yeah. Real image same side as the reflected ray. Virtual image is opposite side of the reflected ray. No light here. Virtual upright magnified. If go even nearer, less than the focal length, it becomes virtual image. So it becomes virtual upright and magnified. Virtual upright, magnified. Okay. So do you see that? For converging, it form read reads when the object moving nearer and nearer. Okay. When the object moving nearer and nearer, the image going further and further away and become bigger and bigger. In the end up become a virtual image. Yeah, object moving nearer and nearer, the image become bigger and bigger. From real become virtual. Actually, the same thing also happened for the convex lens. When the object moving nearer and nearer, the image also become further and further away. And then become bigger and bigger also until in the end become virtual image. You see or not? Object moving nearer, for mirror, object moving nearer, image from moving further. Object moving nearer, image moving further away. And then object moving nearer, image become bigger and bigger. From real become virtual. This one also the same, lens also the same. Object moving nearer and nearer, image moving further and further away. You see, object moving nearer and nearer, image become further and further away. Object moving nearer and nearer, image become bigger and bigger also. And then object moving nearer and nearer, image from real until become virtual. Yeah, look one by one. Object 1 more than the 2f, more than the center curvature, you form real inverted diminished. If object at the center curvature, it form real inverted same size, RIS. Yeah. And then object between f and c, it form real inverted magnified. Object at focal point, it form at infinity. Also this one, real inverted magnified or virtual upright magnified. Can form two type of image, either is at the real inverted magnified or virtual upright magnified. Both at infinity. And if object before less than focal length, it form virtual upright magnified in the end. Understand? Okay. Why this is real inverted magnified? Because it follow this one lah, real inverted magnified. Why this is virtual upright magnified at infinity? Because it follow the last one, virtual upright magnified. Understand? Okay, now about the diverging. Diverging, for converging, it has many characteristics. For converging, what I can summarize over here, converging, it can form, first it form reed, then it form RIS, it form rim, it form rim, boom, infinity, at last it form boom. Yeah, for concave mirror and convex lens, this is the characteristics. Yeah, both of these are converging. But for diverging, only one characteristic, which is voot. Voot only. Voot. Voot. Virtual upright diminish. Not the same, not the things. For if you have a virtual but magnified image, they must belong to the converging series. It's either concave mirror or convex lens. But if you have a virtual and diminished image, virtual but diminished image, means it is the diverging series. Diverging series means it's either convex mirror or concave lens. Okay, so it's only one characteristic. And no matter where's the object you place, more than focal length or more than center curvature. I draw this wrongly. I draw this wrongly. This one should be this one should be the focal point and center curvature. Okay. Now, no matter where is the object. Okay. Same thing for the lens also. No matter where is the object, it only end up with one characteristic, which is virtual upright diminished image. Yeah, upright diminished. So yeah, that's about it. Yeah, it only form virtual diminished image. Okay, now let's say I have one question. The question says that magnification equal to let's say the question give you a hint -2. It form an image with this magnification equal to -2. What can you conclude from this? It use what type of image? And it use what type of mirror? Let's talk about mirror. It use what type of mirror? -2 means, negative means what? Inverted. Negative m means inverted. 2 means what? 2 means if inverted means you see or not? Real is always inverted image. Real is always inverted. And then virtual is always upright. That's why I say in the beginning of the lesson I talk about revu. Real image is always inverted. Real image is always inverted. You see that? Revu. Then this one also vu. You see or not? Revu. Real is always inverted, virtual is always upright. So what I can say is a real image is always V positive. Then the inverted image means the magnification need to be negative. HI also negative. Yeah, and then virtual image means it is V negative. Upright image means the magnification and HI must be positive. Understand that? So now I have one question. Magnification equal to -2. Just this one given in the question. He said it is a -2 image. It form a -2 image. What does it mean? It means that this is an inverted image. Inverted image means it is a real image. Inverted image, real image. And then 2, this is more than 1. This means this is a magnified image. Magnified image. So I can, from here, I can know this is a real inverted magnified image. What type of mirror? What type of mirror? Real inverted magnified. What type of mirror can form real inverted magnified? Of course, the converging one. Converging one can form real inverted magnified, which is the concave mirror. Converging because it can focus light. So this is the only the concave mirror can form this one. Concave mirror, or if you use lens, it's a convex lens. It's a convex lens. Convex lens. You see, so from magnification only, I can know everything. I can know what type of mirror and what type of lens you use. Let's say if you have, let's say the question give you magnification equal to, positive 3. Positive 3. Magnification equal to positive 3. So what type of mirror, what type of lens is used? And what about magnification equal to positive 0.3? What type of mirror is this? This is a quiz, a very good quiz. Now, if positive 3 means what type of image first? First, you must know what type of image. Positive means upright. Positive M means upright. 3 means more than 1. 3 means more than 1 means is magnified. Okay, and another thing. This is a virtual or real image. I told you already, if upright, VU. It must be virtual, VU. Okay, just now is isn't it? Real inverted. Only has real inverted and VU, virtual upright. You see not? Virtual upright. This one just now is real inverted, this one upright means is virtual. Virtual means is VU. VU. And then VU magnified. So this is a VUM. What type of, this is normally the objective question like to ask. Detect what type of mirror or lens you use. Okay, what type of mirror or lens can form VUM? Is it the diverging lens or diverging mirror? Not just the diverging can form virtual image. Even the converging also can form virtual image. It's just that converging can form VUM, diverging can form only VUT. Can form only the VUT. That's the difference. Converging can form VUM, diverging can form VUT. Okay. So this is VUT. VUT means this is what type of let's say if mirror, what type of mirror is this? Can form VUM. This one must be converging. Just now the rim, this is all converging. Converging. And this one VUM also is belong to converging series. Converging series. So VUM, this one must be concave mirror also. Concave mirror. Converging. Then VUM. What type of this one can converge a light? Convex lens also can converge a light. The fat guy. Convex lens is the fat guy. Convex lens. Convex lens. So it can form. So this one is I use either concave mirror or convex lens. How about this one? How about magnification equal to positive 3, 0.3? So what is this? This positive means what? Positive means upright. Yeah, upright. So what type of image is upright? What type of image is upright? VU. Virtual. Virtual. So VU. Okay, and then this one is 0.3, less than 1, isn't it? Less than 1 means it's diminished. Diminished. diminish, become smaller. So this characteristic is wood. Wood. What type of what type of image? What type of mirror form the wood? Diverging. Wood. Yeah. Diverging is either the convex mirror can diverge a light. Only the convex mirror can diverge a light away. Or the concave lens can diverge a light away. You see, convex mirror or concave lens. So if you want to ask me the type of mirror or lens, I just say it's diverging series. Diverging series, that means for convex mirror lah. Convex mirror, it diverge a light away, and then also the concave lens, use lens. Okay. So that's it. That's for the this one. Okay, understand? Diverging and converging, and from the magnification only, I can know everything. What type of mirror also I can detect. What type of lens also I can detect. So that's the thing lah. Converging can form reed, wrist, rim, boom, so the infinity one, and diverging only form one type, which is virtual upright diminished, wood. Okay, so that's all. Concave mirror is just like convex lens. Convex mirror is just like concave lens. Concave, convex, convex, concave. Very confusing if just the word alone. But if you draw out the diagram, the shape, from the shape itself, you can easily know. Concave mirror can focus the light. The fat guy also focus the light. But the convex mirror diverge the light. The concave lens also diverge the light. From the shape itself, you can know it's converging or diverging. That's all for today's videos. Thank you for your patience and your interest. See you again in the next. Bye.